So now that you've seen how we can use a semaphore to mediate access to a shared resource or shared resources, let's take another look at a different use case, which is how to use semaphores to coordinate interactions between threads. And this particular example is going to use this Ping Pong app. And this is an app that coordinates thread interactions by various Java synchronizers, including Java semaphores, in order to alternate printing ping and Pong on the display. And you can get this app here at this link and play around with it and run it. It's pretty cool. So it says ping, Pong for the first round, then second round, ping, Pong, then ping, Pong third round, ping, Pong fourth round, et cetera, et cetera. And so you'll see how we're going to use semaphores to make this work. Here's the UML sequence diagram for the Ping Pong app. This app can be configured to use a pair of semaphores that coordinate the order in which the ping and Pong threads are called to play ping pong. So here's the two semaphores, the ping semaphore and the Pong semaphore. So they're two binary semaphores. Here's the way this works. The app starts up and the main thread will create two other threads. One thread is the ping thread, one thread is the Pong thread. And then both those threads will be started. And they're going to alternate printing ping and Pong, respectively. You can imagine which one prints ping and which one prints Pong. The ping pong thread class implements the core ping pong algorithm, but it defers all the synchronization aspects to subclasses by using the famous template method pattern, which is one of the patterns from the Gang of Four book that hopefully you learned about when you were taking the intermediate software design course here, if you took it here. So here's kind of what it looks like. So we start out by creating two semaphores. One is the ping semaphore, one is the Pong semaphore. The ping semaphore is initialized to 1, and that means it's available or it's not acquired. Conversely, the Pong semaphore is initialized to 0, which means that it's in use or acquired. And we do it this way so that ping goes first, and then Pong will go second. So the Pong semaphore starts out locked, the ping semaphore starts out unlocked, and then you're going to see they're going to alternate their locking behavior. These are both treated as binary semaphores. They only have 0 or 1 as their values, even though Java semaphore allows more than that. You can do counting semaphores with Java semaphores, as we saw with our Palantiri simulator example, but for this particular use case, we're sticking with binary semaphore semantics. And then here's how this works. So the ping thread will start by calling acquire on the ping semaphore. And because that starts out unlocked, it'll decrement it by 1 and go ahead and print ping. And then what it'll do, well, okay, so that's what the ping semaphore does, the ping thread does. The Pong thread starts out by calling acquire, but it's calling acquire on the Pong semaphore. And if you recall, the Pong semaphore started out locked. So it'll block on Pong. So the Pong thread will not go first, the ping thread will go first. And then what the ping thread will do is after it prints out ping and the iteration count, it will then turn around and release the Pong semaphore, which was locked. And that'll allow the Pong thread to wake up, return from acquire, print Pong for that iteration count, and then it'll turn around and release the ping semaphore. So remember, we acquired it up here, so now it's locked. And then down here, the Pong thread releases the ping semaphore so that that thread can then wake up and it can go and do ping for the next round of this iteration. So they'll alternate going ping 1, Pong 1, ping 2, Pong 2, ping 3, Pong 3, et cetera, et cetera, et cetera. So this example does not fully bracket the acquiring and releasing of permits. In particular, the thread that acquires a semaphore is different from the thread that releases it. That's the main important difference. So this is actually what the code looks like. Here's the acquire method. Acquire acquires your own semaphore and releases the other semaphore. And the way it works is that one thread starts out with mine starting out with the ping semaphore, and the other thread starts out with m mine starting out to be the Pong semaphore, and then the m other is just the other one. So it's a really clever implementation. When all the pinging and ponging is finished, then both the ping thread and the Pong thread go away, and the play ping pong thread, which has been waiting patiently, will have the barrier synchronization concluded, and it'll join with the results, and it's all finished. So that's the end of the example that shows how to coordinate threads using a Java semaphore.